I did say that. It's in radians and degrees.
Oh, okay.
It's in both. You have to speak both languages today. So, here's the issue. How good are you at converting radians? Do you remember?
No.
So it's something you're going to have to get on board with today. We can do a small crash course before we get started. Y'all ready for that?
Yes.
So to convert from degrees to radians. Let's go with an easy one. How about 90 degrees? Well, that's an
Wow.
How about converting 90 degrees to radians?
It's pi over 180.
You multiply by
Pi over 180.
pi over 180. Now in this instance, what happens? It is pi over 2. So going 90 degrees is the same as pi over 2 radians. Another important one would be like 180 degrees. So remember, if you're going to convert to radians, you just slap a pi and a 180 on it. And 180 degrees is pi. So good with conversion. So with converting to radians today, you're going to have to be able to count with fractions. I don't think you're going to need that as much today as you probably anticipate that you will. So why is it called the unit circle? No clue. So it is a circle, right, Wyatt?
Yes.
And it's a circle on the coordinate plane. It's a circle on the coordinate plane. But why? And you said, what else did you say about the unit circle?
It has a
There's
radius of 1.
a radius of 1. So as we move through this, we can already do kind of the first topic. We can find out the coordinate location of those 4 points where that circle intersects each axis. The radius is 1. So how do I get from here to here?
1.
Wait, from the origin?
1. 0 1. Wait, 1 0.
Wouldn't it be
Zero.
the
So
same?
over 1 and up 0. That is the coordinate location 1 0. That one's huge.
I thought you meant like from
But wouldn't the other one be negative one?
How do I get to here?
the.
Over 0,
Okay.
up 1.
Negative over negative 1 and up 0. Down 1 and down 1 and
0 negative 1.
Dude. It's tough, right? So as we do that, look, there's already 8 responses. 8 of them. Because there's 1 for each coordinate, and you could mistakenly say 0, 1, and I have to count it wrong. Even though you're kind of right. There's 50 total.
50?
So now we have to go through and do the degree marks. I mean, most of you guys are confident with degrees. How many? This is a hard conversation too. When we count degrees, we always start here, right? And we're like radiating this angle around the circle. So how many degrees is that angle?
180.
From here to here. 0 degrees. Right? That's a 0 degree angle. Now, as I use this x-axis as the other side of my angle, how many degrees is that? 90.
180. 270.
270. And we go all the way back around to 360 degrees. But can you count in radians?
Yes. That's
Pi over 2,
Pi over
pi.
and then
Why would you start at pi over 2?
for 90.
No.
0.
0!
Yes. Yeah.
Let's start at 0. That is an answer as well. This is 0 radians or 0 pi's. I told y'all, that was very clear. Do not write on that until I write on it.
I thought that's what that was.
No, this is what I'm talking about. When I write on that, you write on that. Just hopefully you didn't make any mistakes.
Alright, I'm just stop now.
Okay, 0 radians And you said pi over 2?
Pi over 2
Pi
for
over
the
2
90
is
degrees.
Does anybody else just know that one?
Yeah.
So you could convert 90 degrees, which
It's just equal to pi over 2.
now because you have that one thing, you should just be able to count. This is 0 pi over 2, so 0. 1 pi over 2,
2 pi over
2 pi over 2, but you don't put 2 pi over 2s,
For pi.
it's just pi.
3 over 2 pi.
So 0 pi is over 2, 1 pi over 2, 2 pi over 2,
3 pi over
3 pi over 2,
2.
2 pi.
4 pi over 2, aka
2 pi.
2 pi. That's really weird.
It kind of sounds like a pi.
2 pi radians. Let's just take a small detour. Circumference is equal to 2 pi r, right? It's the radius of the circle.
1.
1
2 pi.
or 2 pi. That's why it counts in radians.
And it's 1 because the radius is 1.
The radius is 1. That's why it's 2 times pi times 1. So here's a tough question. How many radians is this?
Pi.
1 radian or pi radians?
1 pi.
No, this is pi radians. Pi radians. AKA 3.14 radians. So where is 1 radian?
At 180 degrees.
And that's weird, isn't it?
Why would it be?
1 radian's like right here.
That's kind of dumb.
No, that's like for real math. So this is 2 pi radians or 6.28 radians, depending on which language you're speaking. You can speak pi language or you can speak decimal language. So 2 radians is like over here. 3 radians is like right here. But 3.14 radians is right here. That's why we count with fractions, because it's easier to understand. So that's the first kind of chunk of your quiz right there. Now let's go to our unit circle and fill that stuff in. So this should be, I'm doing mine in black because I'm kind of following this order over here. The coordinate location.
1 0.
I recommend doing all the coordinates first.
0 1.
0, 1,
Negative 1 0.
negative 1, 0, 0, negative 1. Do you want to go degrees first or radians?
Radius.
Radians first. Bold move, Cotton. Radians would be over here where the
0.
degree mark is not. 0 radians.
Pi over 2.
Pi over 2 radians.
Pi.
Pi radians.
3 over 3 pi. 3 pi
Pi
over
over
3 pi over 2 radians.
2 pi if radians.
2 pi radians. So if you can't do it like that, you can count. 0 radians. So pi over 2 radians. 2 pi over 2 radians. 3 pi over 2 radians. 4 pi over 2 radians. Now we do degrees. 0,
90.
90, 180, 270, 360. 48 more.
40.
Look at all those blanks.
What?
Look at all those blanks. Look at all them chickens. All right.
So
So,
you have to do 0, 1, 2, 3.
huh?
You can do like 0, 1.
So now we're gonna look at specifically a 45-degree angle. That's the next place I go. 45-degree angles. That would be halfway between the x-axis and the y-axis. So if I drew a 45-degree angle right here, it would create a 45, 45, 90 right triangle.
No way.
But you have to have at least one side.
1.
Which one?
The hypotenuse.
The hypotenuse is 1 because the
That's the
radius
radius.
of the circle is 1.
No
So you have the mathematical capabilities to solve for this length and this length. How do you get from a hypotenuse to a leg?
Divide by the square root of 2.
So 1 divided by the square root of 2. You have to rationalize the denominator. 1 times the square root of 2. The square root of 2 times the square root of 2.
2 square root of 2 over 2.
So this is the square root of 2 over 2. And
Square root of 2 over 2.
is that even
That sounds so weird.
does that even do anything?
Where did the 1 come
That is the radius of the circle. So no matter where I go from the origin to the outside of the circle, it's always going to be 1 unit long. Like, so what was even the point of doing that?
from?
That's what I was thinking.
Guess what? Now I have the coordinates of that dot right here. I have this coordinate now. How do you get there?
Over square
You
root
go
of 2.
over the square root of 2 over 2, and you go up the square root of 2 over 2. Because I went the square root of 2 over 2 in the x direction, and then I went the square root of 2 over 2 in the y direction. That's like, okay, if I speak it in like better language, it's like 0.7 to the right and 0.7 up. And it's just hard to say. So guess what? We have to do that.
Yeah. Just change the slide, right?
Well done. If I draw a triangle this direction, it's still a 45, 45, 90. The hypotenuse is still 1. Is that going to change the side lengths? So this is still the square root of 2 over 2. But instead of going right the square root of 2 over 2, you have to go left the square root of 2 over 2. So that means that this coordinate location would be negative square root of 2 over 2, comma, positive the square root of 2 over 2. And that makes sense because that's quadrant number 2, and all points in quadrant number 2 are negative positive. Oh. So could you figure out what this coordinate location is?
Negative
Being
square root
both
of 2 over 2.
negatives.
Negative square root of 2 over 2.
One on the right, so square root of 2 over 2. Yeah, that.
It's hard to say. It's hard to say. So by just creating this one 45, 45, 90 right triangle and solving for a leg, it gave me the distance right and the distance up to get to that coordinate location, and everything else will be a reflection of that. Would you like to do degrees or radians? Degrees should be fine. So to get it from here to here, 0 degrees,
45
45 degrees. Check. 90 degrees, right? That's correct.
45.
90 plus 45.
90.
135.
135.
180,
180.
correct. 45 more,
Oh, yeah.
45 more, 270. That's an intermediate check step. 45 more, 45 more is 360. So when you count by pi over, or when you count by 45 degrees, what is the radian equivalent? So you might have to convert it. Multiply it by pi over 180, and that should return, and you're counting by quarters. So you go 0/4, 1 pi over 4,
And then isn't it
2 pi over 4, which is
pi over
pi over 2, which is 90.
3
3 pi over 4s,
pi
4 pi over 4s, pi,
5
5 pi over 4s, 6,
pi
which is 3 pi over 2,
Oh my gosh.
7 pi over 8 pi over
8 pi over 4.
2 pi.
Over 4.
So
pi over 4.
Why would it be 4?
Because it's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So when you count by 45s, you're counting by quarters.
Pi day. Isn't that like the anniversary?
Can we just like have a day where we have like a pie with numbers on it? Just
Sure,
put
on
it-
Pi Day, we'll just have a pie party.
Can we?
Alright.
Is
It's
it Pi day
Saturday.
like a Saturday?
Here we go. So now I'm going to do this in blue for 45 degrees so you guys can see the measurements. So you have your notes. This is where people always make mistakes. You have to skip the first one. That's 30 degrees. Then you have to go to 45.
Wait, so the first one makes it 30, 60, 90?
Wait, what's that?
Bakery makes at Wyatt via YouTube. So this is the square root of 2 over 2, comma, the square root of 2 over 2. If you know that one coordinate location, everything else is reflected. So I'm going to keep with the coordinates. I reflect this coordinate across the y-axis and it becomes
Negative square root of 2 over 2 and square root of 2 over 2. Negative square root of 2 over 2. Negative square root of 2. Square root of 2 over 2. Negative square root of 2.
so all 4 of those, or all 8 of those responses have been handled. So radians or degrees.
Degrees.
So 0,
45.
45, 90, 135, 180, 225, 270, 315, 360. Now we count by radians. How many degrees or how many radians is 45 degrees? Pi over 4. So I have 0 pi's over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4,
7 pi.
8 pi over 4. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 32 more.
What?
Wait, why are we skipping every other one? Like,
That's a good question. Because this blank right here is for 30 degrees, 45 degrees, 60 degrees, 90 degrees. So those are all increments that we're counting. Huh? Why did I skip those? Because those are like the harder ones.
What?
Now, do you have to do it like that when you take your quiz? No. Alright, so I'm gonna go with 30 degrees next. So 30 degrees is this small measurement from the origin to the first dot. This is a 30-degree angle.
60.
So that's 90. That has to be 60.
No.
Star.
No.
Yeah, that's what we have to do. You have to know what the hypotenuse is. How long is the hypotenuse?
1.
1.
No.
When you start there, opposite of the star is your 1.
1, yeah.
Then you go to the hypotenuse, and the other side is the square root of 3. Remember, you cannot math around the star. So to go from the hypotenuse to the short leg, how do you get from 2 to 1?
Divide by 2.
Divide by 2. So 1 divided by 2 is 1/2. Then to get from the 1 side to the square root of 3 side, you must multiply by the square root of 3. So 1/2 times the square root of 3 is the square root of 3 over 2. Which is just unleash the actual coordinate location for that first dot. You go the square root of 3 over 2 to the right, which is like 0.85, and you go up 1/2. And then we have three other ones to do.
Like, can we,
So I'm skipping the other dot because I'm always counting the degree measurement from the axis. So that's another 30, 60, 90 right triangle. How long should this side be?
-3.
The negative square root of 3 over 2 up 1/2. So the coordinate location is negative square root of 3 over 2, 1/2. Then you keep moving down. So what is, can we figure out what this one is? How far left do we have to go to get there?
Negative square root of
negative
3
negative square root
What
of 3 over
negative?
2.
But down,
Down,
-1/2.
negative 1/2.
down 1/2. We have to go right the square root of 3 over 2,
Down,
down
1/2.
1/2. So counting degrees here is a little weird, but we need to try and do this together. So with degrees, most people make mistakes by including the 45-degree marks. You can't do that. Because when you count 30, 60, 90, you have to skip a dot. Alright, I can't go 30, 60, 90, 120. Does that make any sense?
No.
So as we count degrees, this is 30 degrees, 60, 90,
120,
120.
150,
This is 150 degrees. 180. So a checkpoint right here. 180 plus 30.
210, 240, 270, 360.
360. So now we have to keep going with radian measures. So I need to convert 30 degrees to radians. How many 30s going to 180?
6.
So I need to count by pi over 6s.
Oh, 1 pi over 6.
1 pi over 6,
2 pi over 6.
2 pi over 6,
3 pi over
3 pi over 6, 4 pi over 6,
5 pi over 6.
6 pi over 6,
7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 12 pi over 6. Wait, 11 pi over 6. 12 pi over 6.
So that's a really intuitive step because you have to know what dots to skip. So I'm gonna go do this one on the actual unit circle. I'm gonna do it in red because we counted by 30 degrees. So let's do degrees first. That's kind of the easiest thing to do. 0, 30,
6. 120. 150. 180.
210.
210.
240,
240.
270, 300, 330. We count by radians. We're counting by pi over 6s. So pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6. 6 pi over 6, which is 180, 7 pi over 6. 8 pi over 6, 9 pi over 6, which is 3 pi over 2, 10 pi over 6,
11 pi over 6.
or that's 2 pi over 6 minus 1 pi over 6.
So fill out this whole thing on the quiz.
No, on the,
How do you know which ones to skip?
you're not, I got you.
Wait,
So-
it's not on the, it's on the quiz, right?
The quiz is a portion of this, and I don't think you're gonna need to like have to know which ones to skip for the quiz. I'm gonna kind of teach you an alternative method to this, which will probably do this whole unit circle in less than a minute. All of it.
I think we had that one sub one time, who showed us like
Did
this
you
stuff.
notice this? I was really confused.
Does it make more sense now?
Yeah.
A little bit. It's right. It's still disgusting, isn't it? It's still gross. It's a lot of rote memorization. So when we go to our actual coordinate locations, you might have to look at your notes.
Square root of 3
So that one coordinate is just reflected across each axis. So this will be the negative square root of 3 over 2, up 1/2. The negative square root of 3 over 2, down 1/2. And the positive square root of 3 over 2, down 1/2. So when you fill it in on this one, you kind of know we only have 16 of them left. That's going to be our 60-degree angles. So if I draw from here up to the last dot, that should be a 60-degree angle. Oh my God. Another 30, 60, 90, right triangle.
So hard.
You have to remember that the radius is 1.
Are you there?
Start here. Plug in the phone.
Are you there?
You gotta get to that.
What's up? Yeah. Oh. I am not dressed for that. I have jeans and a Canyon shirt on. Okay. Yeah. Alright, I cleared that. It's kind of okay. Oh. It's today? I don't, it started at 11:30? Okay. So, is there anybody, like, what time does it end? Okay. Okay, so. Yeah. Yeah, let me finish what I'm doing and I'll head over there. Alright, so, sorry.
What's that?
1, 2, and square root of 3. Divide by 2, multiply by the square root of 3. Alright, so I need to speed through this little part. So we'll go back to the unit circle. This is the coordinate location. Up 1/2 over the square root of 3 over 2. And everything else is reflected. So this is still going to be, it's going to be right 1/2 and up the square root of 3 over 2. So this will be left 1/2 up the square root of 3 over 2. This will be left 1/2 down the square root of 3 over 2. And this will be right 1/2 down the negative square root of 3 over 2. So this is also a negative. Alright, as we count these, we're still going to count by pi over 6s, or 30, 60, 90,
120.
120. So we're counting by 30s. 150, 180, 210,
220.
240,
270.
270,
300.
300, 330, 360. Then we count by pi over 6s, still 1 pi over 6, 2 pi over 6, which is really pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is really
2 pi over 3.
4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, 10 pi over 6, which is 5 pi over 3.
Hey, you did it all.
Yeah. So you have to do the first quadrant on your quiz from scratch. The first quadrant on your quiz from scratch. So
To under everything and count.
this is exactly what I recommend doing. You're gonna see this on your quiz. You're gonna have dot, 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 and you have to give the coordinate location of each. And you have to give degree measurements and radian measurements. So the easiest ones to do are the first ones. Over 1 of 0. Over 0 of 1. And then this is what can you count? Can you count?
Yes.
So when you count 0, 1, 2, 3.
And then it cycles back.
0, 1, 2, 3. Everything gets halved. And everything that's not a 1 gets a square root. Mic drop. So that is the entire thing. That's the entire first quadrant. It goes 0, 1, 2, 3, 0, 1, 2, 3. Everything gets halved, everything that's not a 1 gets a square root. And then when you do your pi measurements, I like to say 2, 3, 4, 6. Look, sorry.
What is that?
It's like an added like little extra.
So 2, 3, 4, 6. Then you can count, 30, 45, 60, 90. The whole unit circle is just a reflection of that. The only thing that sucks is you have to count by degrees or count by pies to get to the right radian locations. So on the quiz, this is the expectation right here. That's how you get 10 responses for the unit circle. Really, it's 15 responses for the unit circle. Right? And then on the test, in the future, I will just randomly pick, I want all of this one, I just want the radians of that one, I just want the coordinate location of this one, I just want the degrees of that one. So they'll just be sporadically placed in there. It's a tough monster right there. So I don't have an assignment to give you for this one. I don't really know what to tell you about that. But I would definitely recommend trying quadrant 1 a few times by yourself on a scratch sheet of paper to see where you're at. Tomorrow is just going to be special right triangles practice out of the book.